Okay, let's take a look at this density curve. So consider the density curve plotted below. Because this is a density curve, I know that the area between the curve and the x-axis, that area always amounts to 1 because of the density curve. So when it's a density curve, that area in there is always equal to 1. And we're going to use that fact sometimes. Let's see if we have to use that here to find these areas. So the first one we're looking for is the probability that x is less than or equal to 19. Well, that means I'm coming up to 19, and I'm looking for the area to the left of it because I'm looking for the probability of being less than or equal to 19. So I'm looking for the area here to the left of 19, which means I'm looking for all this area right here. Now, the good thing is this is just a rectangle, and the area of a rectangle is an easy formula. The area of a rectangle is just its length times its width. So in this specific case, from side to side here, the length of this rectangle takes us from 10 to 9. So length is 9. And the width is the height here from bottom to top, which is 0.1. So that's length times width is 9 times 0.1. So the probability that x is less than or equal to 19 is equal to 90%. It's a 90% chance that you get a number between 10 and 19 from this process. All right, the second part, part 2 here. Let's see. We're looking at the probability that x is greater than 11. Notice the previous one was less than or equal to, and this one is just greater than. There's no or equal to part. But for continuous random variables, that doesn't matter because the probability of any one specific value is 0. So the probability that x would equal 11 is 0. So finding the probability that x is greater than or equal to 11 and finding the probability of that x is greater than 11 for a continuous distribution amounts to the same number. So we find 11, and we're looking for the area to the right because we have greater than. So I'm looking for the area to the right of 11, but still under that red horizontal line. So I'm looking for this much here. And once again, if I'm looking for that area, it's just length times width. Well, the length side to side is from 11 to 20. That's also 9. So the length is also 9 here. And the width, which is the height from top to bottom, that's this distance here, right? That's still 0.1. That's still 0.1. So it turns out that this is also 90%. So the probability that x is greater than 11 is 90% also.